seconds. We have some people here that would like a bit of a continuation from the last Nix Hour, which was about how can we make Flake with a Python library supporting arbitrary Python versions. So last time we didn't really address the Flake aspect, and I'm not sure how well I can address this since I'm not a Flake expert, or I wouldn't say I'm an expert in Flakes. And some discussions has happened in the issue here. So, okay. Yeah, I'm just briefly looking at this. All right, how to write tests for flakes, and then a whole bunch of, these are all flakes related, yeah. Okay, well, maybe let's maybe try to do a flake introduction as I would maybe do it, or how I can best present it. We do have a question in the chat here as well. And we have some other commentary right here as well. Since we have another question here, maybe let's go for that instead. So the question, I'm just going to read it. How are companies, corporates integrating Nix with ecosystems like Rust and NPM? What are the challenges, pros, cons for which domains, web, question mark. Yeah, that's also a fairly hard to answer question, but I'm gonna give it a brief go. So integrating Nix with ecosystems like Rust and NPM. So that's a general question about how you can package things from other package ecosystems, right? Rust has Cargo and NPM has, well, Node.js has NPM. And generally for these, you have a lot of tools like npm to Nix, npm-lock to Nix, and so on. Generally, you'll find those if you just search for things like the combination of the two. We have a wiki article here which lists build npm package, which is actually a new addition to nixpkgs, which allows kind of nice and easy building of npm packages. We have previous approach, yarn to Nix. There's actually two different yarn to Nixes. So it's all of these tools that can do it. I believe there's also a node to Nix that has been very popular for a long time. These tend to be third party. Some of them are also integrated into the main package repository nixpkgs. So in here, I believe if we search for yarn to Nix, there is yarn to Nix Morty, which I believe is a user. If we search for that, Morty, that apparently became the one in nix-community. Maybe also a bit of background here. Nix-community is, I would call it a semi-official GitHub organization. It contains, like, when third-party repositories would like to become a bit more official and community maintained rather than third-party maintained, they can kind of request to be transferred to this organization. And so in here, you'll find a lot of kind of popular things in the community. We have Nor, we have Home Manager, as you saw earlier, various bits. Poetry to Nix is another. Well, a lot of these to Nix tools have been added to the Nix community as well here. So I guess this is also a decently well way to find these. This is not.
Sorry, I'd like to interrupt you. Since you've brought that up, what are the benefits of transferring the project there, except for discoverability?
Yeah, there is, I believe, a team. So we can see here, there's kind of some kind of standard maintainer thing going on here. And so Mick92 is someone in that team, and they kind of take care of these repositories, kind of put them under their umbrella. And I wonder who actually is in all of that team. I'm not sure if we can see this here. Members role, can we see owners? Okay, so this might be the team. We have Mick92, Ryan Team, Jonas, and Addis Bladis, which I think is, forgot the name. But yeah, these are all fairly well-known community members. And so this kind of gives a bit more trust. What?
Adam is his name.
Oh, Adam. Yes. So yeah, I'd say that is an advantage. It gives more trust and more reliability to it, where if the original maintainer isn't maintaining it anymore, someone else can take over. They can also kind of reassign the maintainership and others can take over and so on.
Okay, sorry for
no. Feel free to interrupt. And then we have a question in the chat, and if Python is any indication, all the two Nix tools of it are of various degrees frustrating. Yeah, so there's a lot of different tools for Python. I know there's Nix, I believe, or it's called a bit differently. You can also find them on Discourse, of course, in the announcement category. Every once in a while, you'll see some new tool here. Python distributions managing a roundtable. Yeah, that's something different. But I remember there's MachNix for managing Python. They all come with different trade-offs, and generally there's no one tool that fits all. And currently, so you need to do a bit of research about which one would be best suited. Right, and then there's Dream2Nix, which was mentioned in the channel. This is, as far as I know, still in development. So if you go down here, yeah, it's unstable. It's not yet. It's in development. But this is an idea to unify a lot of these two Nix tools to fix kind of one of the problems where it's kind of hard to discover them. They don't come with the same interface. You want to be able to kind of switch them out and not have to. There's different parts of it. One part is the whole generation aspect, where you might need to generate a log file, and the other aspect is actually building something from that log file. These are separate parts, and Dream2Nix is an effort to kind of split these up. And then other question, do you know which companies have been doing that and publishing content on that, including all or partially of their architectures? I know all those Nixo sponsors, but I would like to see a mapping between all these tech. I don't know if that can be easily seeable. I know at least from the companies I worked for, there are a lot of them using all of these toolings. And they get switched around fairly frequently. So if one of them turns out to be not quite well enough, maybe another one is tried out. Something I can personally report is for Clojure. I worked a bit for Bivuta and created this alternate way of locking or building Clojure projects in Nix. And yeah, this was created when it turned out that another Clojure tooling didn't quite work out, and we needed something different. And so yeah, this is indeed used fairly frequently, if that was the question. Henrik says, I'm currently stuck with a poetry-to-nix thing, but I can't say that I've done the necessary homework research to properly ask the question yet. Yeah, so poetry-to-nix, maybe we can look at this as an example. So I know a bit about this. I've touched it a bit. Poetry-to-nix has the advantage that poetry projects have this poetry.lock file, which conveniently has all of the kind of hashes that Nix needs in usable form. And Nix can easily parse this file because it's a TOML file. Let's see if we can find an example here. Tests. And let's pick anything here. Poetry.lock. Okay, so this is the lock file. It's a TOML file, even though it doesn't have the TOML extension. But in here, if we scroll down here, we can see a lot of these hashes. They're in the SHA-256, which is also supported by Nix. We have the files. I believe these are going to be fetched from pip, PyPy. I'm not sure how you pronounce that actually. But so what Nix can do is it can parse this file at evaluation time. So if we let's get this here. Let's try something like this. So let me get this file. Let's actually do Nix Hour 30. We're going to get this file. All right, we have this poetry.lock file now. And what Nix can do, if we go into repl here, we can do read file, poetry.lock. So now we get the contents of the file. Now we can do built-ins from TOML. Convenient built-in for parsing TOML. And now we have the entire thing in the as a Nix value here. Log file, let's just say value equals this. Now we can say metadata. We have content hash. I'm not sure what that is. Okay. Files.headers. Let's see, can we find a... Oh, this doesn't work. Maybe a brief note here. So we cannot do this, unfortunately. This would be convenient. So this is a list of values, and I just want to inspect the first one here. What we have to do is built-ins.elem or lib.elem at, and then 0, and then the thing. Oh, actually, it's the other way around. So then we get access to this. But in the CLI, or at least in the traditional CLI, we can access it that way. So let's say we have a default.nix and we had an attribute set foo.bar, and then we have a list where the first value is baz equals 10. Now we want to get to this 10. Let's get this. We can do nix instantiate eval-a foo.bar.0.baz. This will get us to the 10. So this is only a CLI thing, but it is very convenient. And but yeah, so the log file, what we can do now using this value
Why is
here,
it only in CLI?
Don't ask me why. If I would have time, I'd make an RFC to also allow this as list element access. I think this would be fairly good in the Nix language as well and wouldn't conflict with anything else. But so what we can do now with this value, and that's what poetry.to-nix does, is we can create a derivation from this. So, well, it's a bit rough here. Actually, let me load nix-pkgs. And then we can do stdnf.make derivation. Actually, stdnf.make derivation should be available here. And it would do something like this, where name something, and as the, say, build command, it would curl something from like pypy.com or something. This might be the attribute name here now. So it might do something like this. And it would output this to out. So that's the kind of basic thing it does. But of course, we don't have internet access by default. In Nix builds, they run in the sandbox. So what you need to do is to provide the output hash. And because we have the hash right here, we can just put it here, and we can say, right, output hash. It's going to get a bit crowded here. Let's put this in the file instead. So it would be make derivation and then output hash. I think it's just like this, and then we'd have to hash here. Shy256. There's various hash formats as well. I'm going to use this one right here. I believe there's. I guess if you do this, you don't need to say the algorithm. I believe there's mode though. I believe that should be flat. The two different modes are flat and recursive, I believe. Where flat just hashes the file itself, and recursive uses the nar format to hash a directory. Nar can be looked up in nix-hash, I believe, or nix. We do nix3 hash. Nix-hash path, yeah. So it's kind of corresponds to these two here. Hashing file and hashing path using the nar serialization of a path. Anyway, so getting back to this is very nice for poetry.to-nix. So poetry provides this log file. This is nice for poetry.to-nix because we can just create these derivations right from here. We don't need to kind of mess around with these hashes in any way. We don't need to create additional log files that have the hashes that we need. And so, yeah, so it's all just at evaluation time, you create the derivations. At build time, you build the derivations, and it works out fine. This is in contrast to, for example, Jan, go ahead.
Yeah, it's even better because Python has a standard format for the file name that's also in the log file, and that includes kind of the target system and the interpreter as well. So that's encoded in there too. So you can even get that out if you want to build a derivation.
Yeah, nice. I didn't know about this. Yeah, so this has a lot of information as well, and I believe poetry.to-nix makes use of a lot of this, including actually, yeah, I believe poetry.to-nix even has a parser for these versions here to kind of encode this at Nix evaluation as well. Yeah, and so this is poetry.to-nix, but if we say, what is the other one? Like a requirements.txt file. And so if we, right, so that would be maybe an alternative if you don't have poetry and nothing locks the dependencies by default. You might have a requirements.txt file like this, which might have some version bounds. It might have, well, it might even have specific URLs, but generally, like if we have PyTest in here, we don't have a hash for this PyTest version. And so the way we then package this in Nix is we run the tool first to fetch PyTest in some way to make sure we have PyTest available. And then, lock this in a custom hash, in the custom log file, or we can compute it at, well, sometimes we can't do it. Sometimes it can be computed in a derivation. I know that I believe Hackage, actually Hackage does this. Hackage has a this is a very interesting one. So this just kind of shows there's various approaches to doing this. There is all-cabal-hashes as a derivation in nixpkgs. So if we build this, actually fairly big, as you can see, like 60 megabytes. If we look at the result of this, what is it? Oh, it's it's tarball. All right, let me unpack this. As you might guess from the name and the contents here, it contains all the hashes for packages on Hackage. So Hackage is the Haskell repository, the Haskell package distribution website. And everybody uploads their packages there. So now if you go to this here, once we have this derivation, we can get access to all the hashes in here. So let's say I want ctar version 0.2.0, and now I can get info about this. We have all the hashes in here, locations, anything. And this is actually, the nice thing is that this is, I believe, even officially maintained. And so all-cabal-hashes. Actually, yeah, we can go into the nixpkgs source here. All-cabal-hashes. Packages. All-cabal-hashes. Let's go to top-level all-packages. Cabal-hashes. Oh, it's a misc Hackage. Of course it is. And where does this come from? This is just a fetch URL. And it fetches, what does it fetch? It fetches from pin, which is this here. So, okay, it's not like 100% official. I don't think this is like the official Haskell one. Although it's also a question like what is even official in Haskell land. But yeah, so this is not actually maintained from Nix people, which is good. So we don't have the maintenance cost of this, and there's some support to it. Yeah, and so this actually, and maybe I can demonstrate this here. This allows something interesting here, which is make package set Hackage, callHackage, yeah, this one here. So okay, we have a short demo in here. So there's this callHackage function in nixpkgs, which you can just pass the name of the package and the version, no hash, but it actually fetches the right package and makes it usable. And if we didn't have the all-cabal-hashes file, and sometimes the all-cabal-hashes file is outdated, in this case, we do need a SHA-256, and so that this version is for that. Yeah, and so this is just an approach to doing the things with the available resources you have. Let me quickly go through the chat here. Okay. Which software engineering architectures patterns are these companies using with Nix? I suppose no MVC. I'm not good on abbreviations. Your enclosures, I suppose data-driven separation between pure and impure function, horizontal microservices. I think it's not. So Nix doesn't really impose any sort of architecture on your software. Because Nix is only really done for the packaging approach. So we can also look at this here. So if we go in nixpkgs and we build something, so we build hello. Well, actually, let's not build hello. Let's just instantiate hello. So once this has passed, Nix isn't really, well, okay, no, Nix is still involved. So right now we just have a recipe for building hello. Once we build this, we can do this using like manually using nix-store realize. So we can build this, and now we get a path to the resulting hello. And this just contains, okay, it's, yeah, well, this just contains the resulting binary then. And at this point, Nix isn't involved anymore. There's no reference to any Nix files anymore. There's no build sandbox involved anymore. And so it really doesn't impose anything in the end. You can still use whatever impure software you might want. Like we could even, like a really kind of stupid example is, let's go into here and do like a impure.nix. And let's just create a, let me do this. Let's just create a packages.write script bin. So write script bin creates a script in the bin folder of the result. And we just do a impure. And in here, we just do a, let me do, I'm going to go into my home directory, or actually let's do this, which nix. Okay, points to this. Just going to do a version of this. So I'm pointing the resulting script to just my home path. And so I can just build this impure.nix and run this impure. And now it's going to run my nix. But on everybody's machine, this is going to return something different, perhaps. And so it just kind of shows that you can have any impure software in the end. There's nothing kind of forcing you to make it pure as in nix-pkgs. Like, I would probably advise you to make this be not your impure nix, because this is going to fail on half the people's systems. If you actually depend on nix, you probably want to do something like this: lib.getBin to get the binary output of nix, and then this.
Maybe get exe.
Get exe.
Yeah.
Oh, is that a new one?
I'm not sure. I'm using it for past several months. It will point to /bin/nix, so you don't have to add it. So.
Oh, I see. Is it lib.get.exe?
Yeah, yeah.
Nice, nice. Yeah, we can also look at this briefly. Lib not defined. Just .lib. All right, and now, right? Yeah, ignore this. Actually, my nix-pkgs version is still way out of date. Fortunately, I'm not really using this. Yeah. But yeah, now it's pinned and it doesn't really depend on my impure path anymore. But yeah, you can have anything impure you need. There was also mentioned, I think we would benefit having sort of a framework for Rust plus node/npm, including all of CI, CD, kind of like Rust on Nails, as I see the community is more inclined towards Rust, Node.js, and Python. Including CI, CD. So maybe I can give a brief shout out. You might want to take a look at Flux. I don't know the current state, but I know they've done some really nice work in the past to kind of get a more integrated experience for CI, CD using Nix as the kind of default. But yeah, maybe check it out, and yeah. And otherwise, what the Nix community tends to do is to set up Nix CI/CD fairly manually. There are some good projects out there as well. So, for example, we have the entire set of cachix services. So we have cachix, which is a binary cache hosting solution. A lot of people use this. I can recommend this. There's also, there's actually Hercules CI, which is a CI kind of built around Nix. I haven't used it personally, but it's from the same team as cachix. So that might work pretty well. There is also on the cachix side, there is things like install-nix-action and cachix-action. This is for GitHub Actions. So GitHub Actions available by default for public repositories with some, well, there's some limits, but it's fairly open. And so a lot of people are just using GitHub Actions, using these cachix-actions here. We could maybe look at an example, actually, probably like poetry to Nix. Like almost every project you'll find probably uses one of this. So CI, we're going to look here, uses cachix install-nix-action. And then we have, does it use a, there's cachix-action as well. So yeah, that's a fairly standard way of doing it. And then maybe also there's different ways of running CI. And so especially for a lot of companies, they have all of their builds in or their builds are fairly impure for their own packages. But they get a lot of dependencies from like repositories and so on. And in a lot of these cases, Nix shell is kind of an easier way to get your product kind of integrated into Nix. So using Nix shell, you would only get, Nix shell, or you can also use Nix shell or Nix shell or Nix develop, although develop, I feel like shell would be more appropriate here. And so this allows you to just get all the dependencies from Nix, but not build your product inside Nix. And so then you also won't have to worry about making sure the build is pure. So you can still have impure builds because inside the Nix shell, I can just do, curl something. Actually, I'm going to unalias Nix shell here, just so it gets me into a bash. Yeah, so I can just curl stuff here. And it's going to work. So you can also do various impure things in here. Of course, the trade-off is it is going to be impure, but it's going to be much easier as kind of an onboarding experience to Nix. Generally, you can like roadmap.markdown. Generally, you get starting with impure deps and build. Then you use Nix for dependencies using Nix shell or Nix shell. And then you, and then on one hand, you want to build something with Nix. So build with Nix, pure build in the sandbox. And then a next step would be deploy with Nix. This has, so generally if you build with Nix, you still have your deployment like set up maybe with a Docker or some other thing which needs to build the product again in of itself. So you don't really have, I guess, the full advantage of the pure build. You can also make this work with like a static build, which then doesn't have any dependencies anymore, and then you can distribute the static build. But if you want to deploy with Nix, you can get runtime dependencies with Nix from Nix. And so you don't deploy just like a single binary or a single tarball. You actually deploy using something like Nix copy closure or Nix, I don't know the equivalent here. But yeah, there you would deploy using this, and that would give you also some benefits. Yuri?
I would like to add that the step of purifying the build itself, it's actually sometimes required before you can start building with Nix, because in many projects, the process of the build process itself includes, for example, fetching dependencies. And if you want to build inside Nix, that should be separated. So I guess the third step would be actually purifying the build, and then we can wrap this build with Nix. And it's very similar to what you said about deployment. You also need your build time dependencies packaged in Nix first before you can actually build everything with Nix. But the benefit of Nix shell is that you can purify your dependencies one by one, add them to your Nix shell, and use them in your usual build process first, and then switch your whole build process into Nix.
Yeah. So, yeah, this is a good point. At kind of this stage, you will probably find that your actual build will make a lot of like web requests or something like that. And those are impure, and then you might need to figure out how can you make those pure. And that's actually how, like, pretty much all of these I'd say most of these tools came to be. So Poetry to Nix was also at some point motivated by, oh, I have a poetry project. If I just call poetry, it's going to try to fetch all of these things, and that's not going to work inside the Nix build. So how can I make this work using Nix? How can I provide the dependencies from Nix directly? So yeah, it's going to feel like it kind of ties the knot back to this. I'm going to read a comment here. Yeah, so just mentioned there's no kind of canonical way in unified solution to use Nix with certain technologies. Also mentioned flakes is a good direction, a good step into the direction of kind of more standardization. Yeah, that's right. So maybe mention, I guess we could transition a bit into flakes now. So flakes is kind of trying to go into more standardization in the Nix world. And that is mainly achieved by kind of having its own standardized input and output scheme. Well, I guess let's first talk a bit about how it would be done traditionally. So let's make your non-flakes. And so generally you would do something like this, where you might have, I want to now declare my build, and I might, right, so I'm always starting off with this, and everybody using flakes will kind of say, oh, you're using impurities. And yes, I'm totally using impurities. I'm using it for simplicity, but flakes would kind of solve this. And so, well, if I wanted to be kind of traditional about it and say, oh, this is an impurity, how do I fix this? It would be pinning nix-pkgs in here. But there's no really good way to kind of detect this. Like you might, okay, let me pin nix-pkgs in here. So I'm going to say, well, let me not fetch it from my Nix path. Let me instead get it from a fetch tarball. I'm going to do URL and then something like GitHub nix-pkgs tarball, and then I'm going to get like, I would probably go into nix-pkgs here and get the latest commit here, or look it up in a channel or somewhere. All right, and then the SHA-256. I'm going to leave this empty for now, and then Nix is going to complain that the hash isn't set, but it will provide me with the right one. Now I can replace this here. Okay, now let me just say hello. Packages.hello. All right, now next build -a hello. And found empty hash, assuming blah, blah, blah. It's going to fetch nix-pkgs. It's going to unpack it, and we get the right hash back. All right, now I'm going here and insert this hash. Now I'm going to build hello, and it works. Okay, but now, let's go into this. Let's go into config, nix-pkgs, overlays, hello, or let's say my hello.nix. And actually, I need to go to config, nix-pkgs. Oh, I already have overlays. Okay, my hello.nix. Now just well, you don't really need to know what I'm doing here. I'm just going to do final pref, and then I'm going to do hello equals nope. All right. I would change the file in my home directory. Now going back to Nix Hour 30 and this non-flakes. So I didn't change anything in my file here. It's still the same file. But if I build this, I suddenly get an error. So, and apparently that's because if I instantiate eval this, it's nope. So a change in my home directory influenced my result here. And so you can dig into this and find out that, oh, I mean, in this case, it's kind of obvious, but overlays are by default looked up in your home directory. And we can override this and prevent this from happening using overlays equals this. Okay, great. Hello is back to being the old one. I can next build hello again, and it works. Okay, impurities fixed, but no, actually, there's another one, and that is config, and we can also we could repeat the same thing with config, which is kind of like this. Config.nix is also a thing. And then here we could do package overrides, and we could say super, and say hello equals again no. All right, I hope I typed this right. I haven't written that file in a while. Yeah, okay, fails again. So config is another one. And so I'm gonna fix this using this config thing here. Okay, and now, I mean, we need to be complete about the impurities here. There's also system as an impurity. And so if, let's say I'm on a different machine, maybe I could even, I'm not gonna try to simulate this, but on a different machine, on a different platform, actually we can we do this? Org, and we can.
I think it was their system.
Oh, that's your system, yeah. So let's do like AR64 Darwin. Okay, well, it works in this case at least, since it's cached, but it's a different result, and so on a Mac Darwin machine, you will get a different result. This is one of the impurities where it's like, should it really be an impurity? Because it's kind of obvious. And so we can fix this as well by just saying this. My system is this one. And yeah, so now if someone else tries to build this on another system, oh, it's gonna work anyways. That's a bit surprising. Oh,
no,
this
but
is
it will produce the same result.
Yeah, so this is the same one. Yes, indeed. So yeah, it produces the same one, but they won't be able to build it anymore. So I mean, let's assume you made a change to this. Let's do like an override. Override address alt, and then do like name equals my hello. This will change the derivation, and now I can build it on my own system. Okay, it's going to build it. But on AR64, you can't build it anymore. Anyways, that's kind of an expectation if you have this kind of purity. And so to kind of not hardcode this, what you often do in the traditional way is you put it as an argument up here. Well, what you generally do is built-in stock current system. Built-in stock current system is an impurity. And that is in fact the default, so it wouldn't really make any difference if we just did it like this. But to make it a bit more kind of generic and customizable, we tend to make this a function argument up here. So we say system is by default built-in stock current system, and then we're just gonna inherit this here to propagate the value. All right, now we can kind of select the system on the CLI here. So, I mean, this works. So we can build it on AR64 Darwin. But we could also say on Linux, we could say argstring system is now ARG64 Darwin. Anyways. Okay, but now let's see how the same, well, actually, one more thing. So here, how did I build hello? Well, I might want to say hello is the kind of default attribute people should build. Generally, what you would do is to kind of try to make just a Nix build without any arguments work. And the way you can do it is by making the package you want people to build to be the result itself. So I'm going to remove the nested attribute set here, and I'm going to put hello directly here. Let me remove the customization. Okay, now Nix build works, but now let's say I also have some formatter or something that I want to build, or some other thing. Let's say curl is needed as a dependency, or shell. Actually, a shell might be a good example. So how do we do this? Because we already have the result. How can we do something else? So one of the ways you can do this is by overriding the result. And so this is an attribute set, like a dictionary. We can just add extra attributes to that. It's still essentially a derivation in the end, but it has some custom things on top. So I might say shell is equal to make shell, and then I'm going to do packages in here and say like, okay, we have curl as a dependency. And then you need to make sure that actually Nix shell uses this shell, and then you might go into like shell.nix and say import default.nix and then access shell. So this is the convention I generally try to use. And now Nix shell works or not, because I didn't specify packages.curl. So now Nix shell works. We have curl available, and Nix build works, and that builds hello. Yeah, but now we have 10 more minutes. Let's look at this in flakes. So how would we do the same thing in flakes? Flakes. All right, let's start with a flake.nix. Now, flakes has inputs and outputs. That's kind of the main scheme of it. And so as an input, well, actually, let's start with outputs. As outputs is a function that kind of takes the inputs and produces the result that we want. Generally, you destructure this here so that you can add the inputs here. You also have a self input by default. That's the output of this flake itself. You can also add like extra dots here in case you have more inputs. I'm going to leave those out for now. And so now flakes provides a standard schema for where things should be. And so we have packages. Actually, the schema, I believe, well, someone tell me where the best place is to look up the schema. I know there's a wiki in flakes here. Which has it input schema, output schema right here. But I believe it should also be documented somewhere.
Inside the man Nix build, there is like what's expected, what does Nix build expects, what outputs, and like Nix shell, Nix check, Nix flake check also specify what they expect.
I believe actually flake check. Oh yeah, it has a little bit here at least. Has some documentation. But yeah, so we have packages.system and then .name. So the way this looks is like this, packages.system. So here I would say this .name, and then this is the hello I want. Right. And so this, actually, let me do something null here, or nope. This is what would be built when you just do a Nix build. So Flakes is integrated into the new CLI, which is it's essentially it kind of drops the dash here, but it also revises the CLI in various ways. So Nix build by default builds flakes. And note, well, flakes is still experimental. I should point this out a bit more visibly. So it's not kind of finalized and things may still break. But if we next build, we get a write message file in a directory. So flakes is also kind of tied to Git repositories. So to actually make this work, I'm going to have to git init here. We are already in a Git repository, but I'm going to just initialize a new one here. And now try next build. Is dirty, no such file or directory, so we need to actually add the file to Git. Flakes only exposes Git tracked files. So I'm going to git add flake.nix and then next build again. Okay, and now we have nar does not provide attribute.default. Oh, so actually, yeah, we need a default one here. So the default one is what gets built by default. Makes a lot of sense. Okay, now it evaluates to a string and not a store path. That's okay. So yeah, this is how we declare the default that should get built. And similarly, def shells is the one that gets used for Nix develop. So once we have def shell set, we again, well, it's still a string right now. But now how do we get nix-pkgs? So that's also where it can make some improvements. So previously, these two things had to be kind of done manually. In this case, we have a convention that does it for us. But so the kind of how we fetch things is also done much more automatic. So we can say inputs.nix-pkgs, that's just an arbitrary name, that URL equals, and I'm going to use GitHub here. Same thing as last time, I want to use GitHub master. So I'm going to do just this. So this is a flake reference. This is a reference to a something mutable that flakes can then pin for you. And so in this case, no pinning yet has happened, but the first time we do a nix build here, it's going to do something here. It's going to fetch nix-pkgs. It integrates with the GitHub GitHub Actions, so it has some kind of smart things about when it needs to update the stuff. All right, now we get nix-pkgs available. Once we have this as an input, we can add it to here. That's what the error was indicating. It doesn't take a nix-pkgs argument. Yeah, so now we have nix-pkgs. Nix-pkgs has all the packages in a legacyPackages attribute. And so actually, if you just do it like this, the flake.nix of the repository gets imported and set as this attribute for one. So if we go to nix-pkgs here, we can see there's a flake.nix down here. And this is what defines these legacyPackages here. And so this would look like this. We're going to do this and hello. And then here we would use nixpkgs.legacyPackages.x6.shell or make shell. Yeah.
Yeah, the legacy packages is also kind of hard for me to grasp why it's needed and what it's actually for, because it seems like just the nix-pkgs input should be kind of enough.
Yeah. I didn't fully get it. Audio is a bit cut off, but so legacyPackages is legacy because I believe the intention is to, well, there's also packages, but legacyPackages contains this kind of recursive package structure where we also have things like Python packages requests and things like that. And those don't quite fit into the Flake schema yet. And so the idea was to kind of deprecate this kind of recursive structure eventually, and but yeah, this hasn't quite happened yet. I'm not sure if that was the question.
Yeah, it kind of was. I just sometimes had the problem of not really having a good heuristic to know when to use legacy packages and when to not. But
yeah, I'd say
nix-pkgs that's also due to a lack of research, I guess.
I'd say for nix-pkgs, it's probably always legacy packages, though I'm not the expert on this, I have to say.
Yeah, in nix-pkgs, there's no packages and only legacy packages, but it's basically if you write your own flake, you shouldn't care about legacy packages. Like if you use from nix-pkgs, you use legacy packages in your own flake. You can do whatever you like, and the structure is actually enforced only by external tooling, like Nix search, for example, that searches through your flake for packages. And I think it will not go deep into packages output, but will go deep into legacy packages output. So it's very arbitrary, I think. So you shouldn't put too much thought into it, basically.
Yeah, and so now I just kind of introduced a variable here. Right, so now something that sticks out here is the x86-64 Linux thing, which is currently hard-coded, so people on other systems won't actually be able to build Hello here. And actually, recently I saw a blog post that kind of showed a very easy way to do this without flake. Well, I mean, just kind of hard-coding the functions instead of using flake-utils. Let me... Is there announcements? Is it an announcement? It was in a blog post. Well, anyways, let me point to flake-utils for now. So to kind of fix this in a convenient way, most people use flake-utils, which is third-party. So it's not. It's a bit. Oh, this is actually default systems. Do it like this. Each default system. Yeah, this is, I believe, the pattern most people use. So we add a flake-utils as an input up here. Then we get flake-utils down here. And then we use this function, each default system, which adds these attributes for all systems and gives us the system argument here to parameterize over. And so I'm going to do the Latin here. I'm going to put everything in here. And then instead of hard coding this here, I'm just going to use system. Same here. System.
No, you don't need system there inside.
Oh, yes. Right. So I believe this each default system actually looks at each attribute in here and kind of adds them for each of the systems here. It's a bit, you do need to watch out though. There are some attributes that don't require system. So the standardization goes a bit further. So you have NixOS configurations, I believe. This is where you can declare your NixOS systems. And notably, each of these attributes have some integration with some tooling. So this is for Nix build, this is for Nix develop, and NixOS configurations is for NixOS rebuild. This is what you would put in your etc nixos flake.nix. Yeah, but so this one actually doesn't need a systems one because it's not specific to any single system. NixOS configurations, that's like, it's a NixOS module. And so this, I believe you'd have to put outside here. So I'm going to close the attributes here and close the function from flake-utils, start it up there. And I'm going to override the rest of this with the NixOS configurations here. and fixing some stuff here. Yeah, we are out of time. I mean, there's much more to talk about for flakes, but we can cover this another time. But yeah, thanks everyone for joining.